All right, so in the last couple of videos, we've been looking at Euler paths and Euler circuits, which hopefully by now you know means that we are traveling every edge exactly one time, okay? A path beginning and ending at any two vertices, a circuit beginning and ending at the same vertex. Well, what happens if we don't want to travel every edge once, but maybe we want to visit every vertex once? Okay, maybe those are different houses or different businesses. You're running errands and you have to get to all those businesses. You don't need to travel every single street. You just need to get to every business one time. Can you do that without having to backtrack, without having to drive past the same business again? Okay, so when a route goes around a connected graph, has to be connected, that visits every vertex once, is called a Hamilton path. Okay, and again, a path can begin and end at different vertices. So Hamilton, sorry, I forgot the L there. A Hamilton path means we're visiting every vertex exactly one time. Okay, a Hamilton path that starts and finishes at the same vertex, but goes through all the other vertices, again, not edges, just every vertex, probably not surprisingly, is called a Hamilton circuit. So we still have those same ideas of paths and circuits, but Euler starts with an E, means every edge, E. Hamilton is the one who discovered or who came up with the idea of visiting every vertex exactly one time. Okay, so we're going to start here with some graphs we've seen before. Okay, these are not new to us. So we're going to look at the first one, and we want to find a Hamilton path. Remember, the whole point here is to visit every vertex exactly one time. So we get to pick a starting point. It doesn't matter what that starting point is. I'm going to start at D just because it kind of seems like a starting line to me. So I'm going to start at vertex D. And from vertex D, I can label that vertex 1 if you want. We get to decide where we want to go next. So, I don't know, let's go up to vertex C as number 2. Okay, we're not going to go back and visit D or C again. We're trying to create a Hamilton path. So from C, I don't know, let's just go ahead and go across to vertex B. Then I still have to visit F and A and E. So if I go to F, I could do that potentially next. I could visit that 4th. Then I could go to E. I could do that 5th. And then notice I can't get to A. Okay? Because if I do, to get to A, I'd have to go back through D. And that's going to be a definite problem. Okay? I can't revisit a vertex. So let's try something slightly different, see if we come up with a different outcome. We can still start at vertex D. Let's see what happens. And again, there's a lot of trial and error here. This is not me being persnickety. This is me trying. I don't have anything in front of me. I'm trying it just as if it was you doing this problem from the beginning. So let's start at D this time. Let's try going to E, see if anything changes. So let's go to E next. After E, I'm going to try F. See if that leads us anywhere different. From F, I could go to C or I could go to B. I'm going to choose, I don't know that it's actually going to matter, but let's go to C just for something different. Let's go that way. Vertex C. And then it is going to matter because look, from vertex C, I can go to B or A and I can't get to the other one. So I'm going to back that up just a little bit. And instead, from F, I'm going to go to B. Then from B, I'm going to go over to C as my 5th vertex, and then I'm going to end up at A, last but not least. Okay, and that time I actually did take the wrong turn on purpose. Just wanted to show you sometimes you don't have to start all the way over. You can kind of notice that, like, wait a minute, if I go there, I'm not going to be able to get to this last vertex. Okay. If we want to find a Hamilton circuit, we have to begin and end at the same vertex. Okay. Begin and end at the same vertex. So I'm going to start at vertex E just for something kind of different here. So if I start at E as number 1, I'm going to head over to F next, number 2. After F, I'm going to go up to B. See if that led me down a good path before. Let's try it again. Then let's see if we go over to C, what would happen next. And I have to end up back at E, remember? And so I don't want to go to D next, because then I could go to E, but then I wouldn't have gone to A. If I go from C to D to A, there's no way back to E. So I think the next most logical choice is to go to A, then head over to D, and then go back to E where we originally started. So there's a Hamilton circuit. All right, for these last two examples, for the first one there with the A, B, C, D, E, I'm going to tell you that you will find a Hamilton path or a Hamilton circuit. You will not find both, okay? So that'll give you at least a little bit of a hint. And then on that last one, I'm not going to tell you anything about it. I'm going to leave it up to you to persevere and find one or the other or both or perhaps neither if that's the case. And then come back after pausing the video and trying it out and see how you did, okay? And again, yours will not necessarily have to match mine exactly. The whole point is that if you go through the vertices, you should have every vertex listed exactly one time if you're a Hamilton path, and for a circuit, one time each except for your starting and ending. Those you can list obviously twice because you got to begin and end at the same spot. All right, so pause the video. Good luck. Okay, again, remembering that these are not necessarily unique for your Hamilton path, you should have every vertex A, B, C, D, E, and E listed exactly one time. There is not a Hamilton circuit. The reason I gave is because I cannot enter and exit vertex E, and you have to be able in a circuit to get in and out of every vertex because you have to be able to start and finish where you began. So once you leave your starting vertex and enter another one, you have to be able to leave that vertex, enter another one, leave that vertex, enter another one, and eventually re-enter your starting point. There's no way to enter and exit vertex E. For my Hamilton path, for the next one, again, making sure you've listed A through I exactly once. That's one possibility. For a Hamilton circuit, I don't think it's possible. And again, there could be other reasons for this, but for me, H is the one that's kind of my hang up in every case, because no matter where I start, whether I start in the ones like around the square at the top, I'm eventually going to have to get to the point where I go down to that triangle, and that's going to have to be through vertex H. And if I'm going to get back where I started, I have to go through H again to get back up to that square, and that's not possible. And in a similar fashion, if I start somewhere in that triangle, again, no matter where it is, and I work my way around, and I get to all these vertices, and I come up here to my square and I wander around, I have to go back through H again to get back where I started, and that's not going to be possible. So I cannot find a Hamilton circuit, and you may have come up with a different vertex that was kind of your hang up and the reason why you couldn't make it work, but that's mine.